Okay, so guys, the other kind of asymptote we can have is a slant asymptote. So look down here at rule number 3 for asymptotes. It says the graph of a function has a slant, it can also be called an oblique asymptote, if the degree of p of x, that's the top, so if the degree of the top is 1 greater than the degree of the bottom. And to find that slant asymptote, we divide p of x by q of x. That's going to give us the equation of that slant asymptote. A graph can cross slant asymptotes, and it usually happens in the middle of the graph. All right, so let's look at some problems then that would have slant asymptotes. Look at letter D. So we have to divide these two. If we could factor, we would, but we can't. So to divide them, we're going to have to use one of our other methods. We have two methods to divide. The two methods we have, does anybody know one? Maya? Synthetic. Does anybody know the other one? Charlie? Yep, long division. Those are the two ways. So you can choose one of those two ways. So when I look at this one, I can say, well, whichever one I want to use. I'm going to go ahead and try to use, I'm going to use long division first. So here's what I do. I have x minus 4, 3x squared plus 0x plus 1. I have to do 3x squared divided by x. That's just going to be 3x. 3x times x is 3x squared. 3x times negative 4 is negative 12. I subtract. And so then I'm going to get just 0 there. And, oh, actually, hold on. I'm going to get 3x. I messed that up. I get 3x squared minus 12x. Now I'm going to have to subtract. So I subtract that and subtract that. So then I'm going to have 12x. And then I do 12x divided by x, and that's going to give me 12. And you can multiply, you get 12x. I really don't care at this point, though, because this is what I want to get. This right here is going to tell me the slant asymptote. So the slant asymptote is going to be 3x plus 12. I could have kept dividing, but all that gives me is the remainder, and the remainder has nothing to do with the slant asymptote. So that's one way to do the problem. What if I decided to use synthetic on this? And we show what would make the denominator 0. So I could put 4 in the box, and then I would use my coefficients. Coefficient of x squared is 3. Coefficient of x is 0. And then I have my constant. I bring this down. 3 times 4 is 12. We add. 4 times 12 is 48. I don't care about that. That's just the remainder. And so this is the equation of my slant asymptote. I needed to put y equals here. Slant asymptote should be y equals 3x plus 12. Make sure you always put y equals or x equals on your asymptotes. They have to be equations. All right, so now you guys choose a way to do this one, whichever way you want, synthetic or long division. Check your answer and make sure you got that. Everybody get y equals x plus 4? All right, excellent. Let's flip over to the back now and let's do some problems with slant asymptotes. So for example 3, I'm going to first of all find the vertical asymptote. Abigail, what is it? X equals 2. We're going to graph as we go. So there's our asymptote. Okay, let's find some other stuff now. We should find our slant asymptote. So however you like to do it the best, I think that the synthetic's easiest. So I put my 2 in there, 1, 0, negative 3. As soon as I get to this point, I know what it is. So I've got y equals x plus 2. And so now I'm going to graph that slant asymptote. The y-intercept of it is 2, and then the slope is 1. So I go up 1 over 1. So it's going to look like this. There's our slant asymptote. All right, so now the question is, what does it look like in the rest of the region? See, it can go here, or it could go here. We need to know which way it goes. So to figure that out, it might be helpful to find our x-intercepts. To find the x-intercepts, you can just set the numerator equal to 0. And then to solve that, I'm just going to add 3 to both sides, and then take the square root. So plus or minus radical 3. Those are going to be the x-intercepts. Anybody know what radical 3 is as a decimal approximately? Drew? Yep, it's about 1.7. So I'm going to put those in here. So I have 1.7 is about right there. Negative 1.7 would be right about here. Let's go ahead and find the y-intercept. Plug in 0 for x. Jake, what do I get for the y-intercept then? So that's going to be right there. So now I know, because of all these dots I've got, I know it's going to have to look like this. That's going to be the way it looks in that region. I pretty much know that these hyperbolics are always going to be like across from one another, these hyperbola shapes we get. But I'm going to go ahead and test a point just to be sure. So I might want to test 3. Plugging in 3, I get 9 minus 3 is 6. 3 minus 2 is 1. 6 over 1 is 6. So if I have the point 36, yep, that supports that. It's going to look like that. The last thing we have to find is the domain and the range. The domain isn't too difficult. The domain is just going to be everything except for our asymptote here of x equals 2. So, Karish, can you tell me the domain?
It would be negative infinity to 2 and 6.
Good. And then to find the range, though, it gets a little tough because I can see the range is going to go from negative infinity to this point, and then it's going to pick back up here. So I'm going to have to use my graphing calculator to find the range. It's the only way to do it. So putting that in, here's the way it looks. So the y values go from negative infinity. I'm going to have to find the maximum right there. So I'm already on the left. I hit enter. Go over to the right, hit enter. Enter one more time. And the maximum is at 2. So the range is going to go from negative infinity to 2. Now, should I use a bracket or a parenthesis there? Is 2 included? It is, isn't it? So I should actually use a bracket on that. And now I need to know where is it going to pick back up. So I'm going to do second calculate a minimum. Oops, there it is. So I had to be on the left side of the minimum, then on the right side of the minimum. One more time, 6. So there's our domain and range. So those are the 6 things we have to find. The asymptotes and the intercepts and the domain and range. Questions there? All right, let's take a look at example 4. Vertical asymptote. What is the vertical asymptote going to be, Sydney? Okay, write it as an equation. So go ahead and put that in. Okay, now we're going to have to find the slant asymptote. So what's going to go in the box then? Mitchell, what goes in the box? So I put that in the box, and then it goes 1, -2, -3. Bring this down. Multiply, add, stop. Becky, what's the slant asymptote's equation then? And we have to say y equals. So I'm going to go to -1, up 1 over 1. So there's our slant asymptote. Okay. And so now I need to know what's happening in between there. So it might be nice to find the X-intercepts. Dominic, do you remember how we find the X-intercepts? Set y equal to just 0. Yep. 0 over 1. So I set y equal to 0. So really that's the same thing as just setting the top equal to 0. Setting the top equal to 0 will find our X-intercepts. So this can be factored. That's always nice. So our X-intercepts then are going to be at 3, 0 and -1, 0. Let's put those in there. Okay, so we got that. Let's go ahead and find the Y-intercepts. Plug in 0 for X, we get 3 for Y. All right, so that tells me then that this graph is not down here like the last one was. This graph goes up like this. It's going like that. And then I know that they have to be diagonal one another because it's a hyperbola, so I can't do those regions, so it's going to have to go like this. And so then my domain is going to be from -infinity to what? Can you tell me the domain, Michaela? Right. And what about the range? What do you guys think the range would be? Tyler, what do you think? Do you agree, Charlie? That's right. Good thing. Okay. So here's all of our important information. The 6 things we need to be able to find. Any questions? Not too bad, right? So let's go ahead and do the evens. You also have those answers are on Canvas if you want to check as